Physics Grade 9 Monthly Review and Exam Review Trial 3. Resistor. Characteristic voltage current of a resistor. It is a straight line passing through the origin. That is Ohm's law. The voltage U across a resistor R and the current I that it carries are related by Ohm's law. U equal Ri. The resistance of a resistor is expressed in SI unit, the ohm. Ohm meter is an instrument used to measure the resistance of a resistor directly. U equal R times I. The unit of U is volt. The unit of R is ohm and the unit of I is ampere. Grouping of resistors. Resistors in series. The two resistors are in series, so R equivalent is equal R1 plus R2. While when the resistor is in parallel, so 1 over R equivalent is equal 1 over R1 plus 1 over R2, or R equivalent equal R1 times R2 over R1 plus R2. Now, electric power and energy. Power. The electric power consumed by an appliance is P equal U times I, but U equal Ri, so substitute instead of U Ri, so Ri square, P equal Ri square. Now substitute instead of I, U equal U over R, so P equal U times I, U times U over R equal U square over R. P equal U square over R. The unit of the power is watt. From milliwatt into watt multiply by 10 power minus 3. From kilowatt into watt multiply by 10 power 3. From megawatt into watt multiply by 10 power 6. Electric energy. The electric energy is the product of the consumed power by the time interval of functioning of an appliance. E equal P times T. E equal U times I times T. E equal Ri square times T, or E equal U square over R times T. Unit of energy. The unit of E is watt hour or joule, J. Relation between units. Convert from watt hour into joule, joule, watt, second. To convert from watt hour into watt second, so we convert hour into second. From hour into second, we multiply by 3600. To convert from 1 kilowatt hour into joule or watt second, so convert first from kilowatt into watt and hour into second. So we multiply by from kilowatt into watt 10 power 3. From hour into second times 3600. So to convert from kilowatt hour into watt second, we multiply by 3600,000. Joules effect. The transformation of electric energy into heat or light energy is called Joules effect. Example: lamp, motor, TV, radio, heater, electric oven, and etc. Joules effect is disadvantage, and its inconveniences is loss of electricity in the form of heat. Now, mechanical action. Classification of forces. Forces classified into two kinds: contact force and forces acting at a distance. Contact force, for example, normal reaction force, force N, friction force, F, tension force, T. Forces acting from a distance, for example, weight, magnetic force, and electric force. Characteristics of a force. Point of application, center of gravity, line of action, horizontal, direction, from right to left or from left to right. Magnitude, F vector equal F magnitude. Its unit is N, Newton. Weight, W equal M times G. W in Newton, M in kilogram. Characteristics of the weight. Point of application, center of gravity, line of action, vertical ward, direction, downward, magnitude, W equal M times G in Newton. Principle of interaction. When a body A exerts on body B force Fa on B, then body B exerts a force on body A, Fb on A. So, Fa on B equal minus Fb on A. They have same line of action, same magnitude, opposite direction. It is very, very important. Equilibrium of a body. F1 plus F2 equal 0. So, F1 and F2 have same line of action, same magnitude, opposite direction. The forces acting on this block are weight from center of gravity, weight, and from contact point, normal. So, at equilibrium, N plus W equals 0, and vector equal minus W vector, N equal W equal M times G. In this figure, we have weight from center of gravity and tension from contact point. At equilibrium, T plus W equals 0, T vector equal minus W vector, T equal W equal M times G. Hooke's law. It is the tension in spring is proportional to the corresponding elongation. T equal K delta L. T is tension in spring. Its unit is N, Newton. K, stiffness or constant of the spring. Its unit is Newton per meter. Delta L or X. It is elongation or compression of the spring. Its unit is meter. In the case of elongation, delta L equal L minus L0. In the case of compression, delta L equal L0 minus L. First exercise. Consider the circuit on the adjacent figure. C1, C2, and C3 are resistors of resistance R1 equal 20 ohm, R2 equal 30 ohm, R3 equal 8 ohm, respectively. The circuit is supplied by a generator of a direct voltage U across AC 6 volt. Number 1. Calculate equivalent resistance between A and B. R equivalent between A and B is equal to R1 times R2 over R1 plus R2. Since R1 and R2 in parallel equal R1 20 times 30 over 20 plus 30. So it's equal 600 over 50, which is equal 12 ohm. Number 2. Calculate equivalent resistance in the circuit. RAB and R3 are in series. So R equivalent equal RAB plus R3 equal RAB 12 plus 8 equal 20 ohm. Number 3. Deduce the intensity of the current produced by the generator. R equivalent in the circuit. R equivalent, current I, voltage AC. U across AC equal I R equivalent using Ohm's law. So I equal U AC over R equivalent equal 6 volt over 20 ohm, which is 0.3 ampere. Number 4. Calculate the voltage UBC and UAB. U across BC equal I3R3 using Ohm's law. I3 equal I equal 0.3 ampere since they are connected in series, equal 0.3 times 8 equal 2.4 volt, while UAB, U across AC equal U across AB plus U across BC since they are connected in series. U across AB AC 6 equal U across AB plus 2.4. So U across AB equals 6 minus 2.4 equals 3.6 volt. Number 5. Calculate the intensity of the current through C1. Voltage U across AB is equal I1 R1. So I1 equal UAB over R1. 3.6 over R1 is equal to 20 equals 0.18 ampere. 6. A short circuit is done on C1 and a voltmeter is connected across the terminals of C3. Draw the figure of the new installation showing the short circuit and the voltmeter. Short circuit and a voltmeter come to -4. B. The voltmeter indicates 6 volt. Justify these indications. U across AB equal 0 volt since short circuit across C1 and C2 in parallel, so the voltage across AB is 0. Voltage across AC equals voltage across AB plus U across BC, since they are connected in series. 6 equals 0 plus UBC, so U across BC equals 6 volts. Knowing that R3 can withstand a maximum voltage of 4 volts, what do we do to protect C3? We use fuse. Second exercise. The object AB is placed at a distance OA 6 cm from the optical center O of L. The diagram below shows L optical axis, F and F prime, object focus and image focus, and the object AB. Reproduce on the graph paper and with the same scale the above figure. 2. Draw on the reproduced figure the image A1B1 of AB with justification. Draw a ray parallel to the optical axis. Immerse the lens passing through F prime. Another ray passing through the optical center. Continue without deviation. The two rays intersect at B1. From B1, draw a perpendicular to optical axis and intersect it at A1. A1B1 is the image of AB. Draw a ray from B parallel to optical axis. Immerse the lens passes through F prime. Another ray. Draw a ray from B passing through optical center. Continuous without deviation. The two rays intersect at B1. From B1, draw a perpendicular to optical axis and intersect it at A1. So A1B1 is the image of AB. 3. Give the nature and the direction of A1B1. Nature, real, direction, inverted with respect to AB. 4. Determine graphically height and position of A1B1. The height A1B1 equal the height 1, 2. 2 times scale 2 centimeter equal 4 centimeter. Position, one, 2, 3, 4, 5, 6. OA1 equals 6 times scale to 12 centimeter. Third exercise, we bring a lamp labeled 100 watt to 120 volt. What is the significance of each of the labeled values? 100 watt, it is a rated power consumed by the lamp to function normally. 220 volt, it is a rated voltage of lamp to function normally. Number 2. How is the lamp connected with other appliances in home? Justify your answer. The lamp is connected in parallel to provide the same voltage across the wall outlets and to function independently. This part is very important. Very important. Don't forget. Number 3. Calculate the electric current that traverses the lamp when it functions normally. P equal U times I. So I equal P over U. P is equal to 100 watt. U is equal to 120 volt. Is equal to 100 over 220. So it's equal to 0.45 ampere. Assume that the lamp functions normally. Calculate in joules and in kilowatt hour the energy consumed by the lamp during 30 minutes. T equal 30 minutes. It is 30 times 60, which is 1800 seconds. P equal 100 watt. It is 100 times 10 power minus 3 is equal 0.1 kilowatt. E equal P times T. First in a joule. Joule means watt second. So we take power in watt. Times T in second, 1800. So it's equal 1800 joule. Now E equal P times T. Now find energy in kilowatt hour. So we take power in kilowatt, 0.1. T in hour, 30 minutes is equal to 0.5 hour. It's equal times 0.5, 0.05 kilowatt hour. B. The price of 1 kilowatt hour is about 50 LL. So 1 kilowatt hour is 50 LL. Calculate how many kilowatt hour we can buy by 500 LL. E prime 500 LL. So E prime equal 500 over 50 equal 10 kilowatt hour. 2. Calculate how many hours this lamp can function if we pay 500 LL. E prime 10 kilowatt hour. P equal 0.1 kilowatt. So E equal P times T, new time. T equal E prime over P equal 10 kilowatt hour over 0.1 kilowatt equal 100 hour. Fourth exercise. The object of this exercise is to determine the stiffness K of an elastic spring R. R is suspended vertically with its upper end O fixed to horizontal support. Its lower end A carries a solid S of center of gravity G and of mass M equals 0.5 kilogram. The solid S is then submitted to two forces, its weight and its tension of the spring. At equilibrium, the elongation of the spring is 10 cm, given G equal 10 Newton per kilogram. 1. Indicate for each of these forces if its contact force or a force acting at a distance. First, weight. The force weight is acting at a distance. Tension, it is contact force. Number 2, indicate the point of application, line of action and direction of W. Point of application, line of action, direction. Point of application is center of gravity of S, which is G. Line of action, vertical ward. Direction, downward. Three. Calculate the magnitude W of the weight W vector. W equal M times G. M equals 0.5. G equal 10. So 0.5 times 10 is equal to 5 Newton. 4. Show that the magnitude of the tension T is equal to 5 Newton. At equilibrium, T plus W equals 0. So T vector equal minus W vector. T equal W equal 5 Newton. Number 5. Determine K. Using Hooke's law, T equal Kx. So K is equal T over X equal 5/10 equal 0.5. Unit of K is Newton per centimeter.